Oh, hello everyone. It's October 27th. I think I resolved a pretty nasty problem in the work, so I feel pretty accomplished. Well, I spent a lot of time today to just dig into this one, keep digging, and then finally kind of got it resolved. I mean, I think I got it resolved, but there's still a lot of mechanism that I don't know. So yeah, we'll see how that one goes. But that also means we have very limited time. It's like kind of the theme of every day, right? You just don't have time. All right, let's just do this one. Longest square streak in an array. Okay. Oh yeah, we haven't even handled this one yet because we said we would do hints. Jeez. Oh man. All right, you're given an integer array. A subsequence of numbers is called a square streak if the length of the subsequence is at least 2, and after sorting the subsequence, each element except the first element is the square of the previous element. Return the length of the longest square streak in nums, or return when -1 if there is no square streak. A subsequence is, yeah, it doesn't really matter. So after sorting, right? So you just sort it. I do believe if you sort it, it will be fine because you do a subsequence, you have to sort it anyway. So you can sort it beforehand and then do subsequence. It's the same thing. So we'll sort. So I have 2, 3, 4, 6, 8, 16, right? So you can say 2. Do we have 4? Yes, we have. So we have 2, 4. Oh, the length of the longest. And then do we have 16? We have 16. Okay, that's 3. That's it. Starting from 2. Now starting from 3, we have 9. We don't have 9. 4, we already used in the previous, so it's not going to happen. So that's it. So we'll do a 10 to the 5th. Okay, we can do a map, right? We can do a map, and then it doesn't matter. It's just a map, and then we sort it, and from small to large, you will go through them, and then check, and then check, and then check. And then once you have checked, once you've checked that one, you can just remove it because it's not going to make any difference once you have checked it, right? If you have checked from a previous one and then it doesn't work, it leads to something that's like, yeah, you only need to check it once. So we can technically go through nums, put it into a Boolean array, and then we go through the Boolean array one by one. And then when we hit 1 and interesting idea. I want to try this. Is that 5? Oh, I can now do 1. Okay. Alright. Hey, I'm not complaining. Definitely not complaining. Alright, here is what I think. We'll do Eligible. Right, eligible. That's not right. Let's do boolean. 10,000 and 1. 1, 2, 3, 4. No, 100,000, not 10,000. Right, 100,000. For int n of nums, eligible n true. Okay. For int I equal to 2, I smaller equal to okay, so we also have the rest equal to 0. Actually, no, -1. Int count equal to 0, right? You know what? That should do 0. That's fine. Count is equal to 0. While eligible if eligible j is true, okay, then count plus plus right, count plus plus and then j times equal to j. And then it has to be larger than 2, right? Eligible j equal to false. There we go. And then we say if count is larger than 2, res math.maximum res and count. Okay, what do you think? Well, I think the fact that we don't have the sort maybe make it fast. My bad, smaller than. Yep, so I return res. So a couple things. First, I don't know why I do this. Doesn't make any sense. Here, if res is equal to 0, we'll return -1, otherwise return res. To sort nums and then use a set to keep keep track of which number, right, exists in nums. Then go from the smallest num, try its square to see if it is in nums. If it is, continue. Otherwise, break out. Right. And each number can only be tried once. To simplify, to speed up, we, instead of sorting and using a set, we use a Boolean array of maximum size. This way, the runtime can be on. Okay. Try one more time. If it's good, we'll submit. See how it goes. Oh, that was not good. Oh my god. That's a typo. Oh gosh. Okay. Yeah. Well, J is smaller than max and yeah, I blame this to the fact that I feel a little bit drowsy now, so I'm definitely not the sharpest as I can be. Not the sharpest for sure. In succession. Oh. Lord. I know why. Oh man. Oh, I think I can do this. Right? Because it has to be like it cannot go outside. It cannot overflow. Like I allow it to overflow. Yeah, I allow it to overflow. There we go. Right, I allow it to overflow. But no, these checks are binary search. A set. A map. So what's the binary search approach? Oh, you sort it and you. Oh, I see. You sort it, and then you. Oh, hold on. This is binary search. You sort it. Keep track numbers we've already processed. If contains, continue. Otherwise, you get a streak. Well, true. You get a value. Binary search. If it's true, this. Otherwise, yeah. Use binary search. That's fine. Use set. So you put everybody in a set. Hash set. Put in hash set. Yep. It's the same. Yeah, because there's no sorting, so that is ON. I don't know. What's your complaint? Oh, the complaint is it's actually O max. Wait, what? That's not true. Oh, because you have this part. But you all have this part, right? You all have this while part. No, this is correct. Is on, and then you go through this. This is exactly the same. I don't know, what's your complaint? A map. You sort. For each number to see if the number is a perfect square. And if it's square is in the map. If so, extend the streak from its square root. Else start a new streak. Because you sorted it, right? Hmm. Okay, yeah. That will work. Yeah, this will work. Yeah, I still don't understand what's your complaint. Is everything gets visited once? Oh, okay. You have all log. You have all log n, a log max here, right? You have. Okay, okay. I see. I see. But it happens to all the other solution as well. See, they all have this looping. But they all have this complaint. I don't understand. Unless they changed it. I don't understand. Oh, because I went to the, for me, yes, I went to the max. But that's not what this one does. This one doesn't go to the max. This one goes through every single one, right? Am I crazy? You have a set, that's On, right? This is On, and then within it, you say whether it contains, right? And then you double it, double it, double it, and oh, because they did not remove it. Oh, I see. Now I see the problem. Oh, yeah. Because they did not remove it. So for everyone you have to try it. For everyone you have to try it. But you don't really have to because once you do it, you can remove it. You can remove it. Now that's the thing. I'm not sure if you can change the set while you're. Yes, you can. I'm not iterating through the set. Yeah, this one can be improved. This one can be improved. Okay, yeah. And I was like, what's the what's the fuss with the runtime? And it turns out, yeah, that runtime does. You have to do log k or log max. Yeah, you have to. But if you remove every time you hit number, then you don't have to, because you don't do the repeated. And that's why this one's fast, because I don't do the repeated thing. Okay, that's it. I'll see you guys tomorrow. Adios.